Dear 12th standard students, in this video we will start a new lesson, atomic and nuclear physics. Actually, atomic physics and nuclear physics is a two separate branch of physics. But in our textbook, both the atomic physics and the nuclear physics, some topics are compiled with a single unit. Before going to enter into the lesson, first we are going to see some introduction about atomic physics and the nuclear physics. See, basic concept, atom. In our earlier class, you studied about anything which occupies by the space is called matter. You know, matter is classified into three groups: solids, liquids, gases. So matter is classified into three groups: solids, liquids, and gases. In our day-to-day life, we use many materials, but characteristics of one material is entirely different from characteristics of another material. Why? Because that each and every material has its own physical and chemical properties. So how we identify the properties and the characteristics of individual material? We need to know the constituent of materials. Generally, take one material, that material is divided repeatedly. That process of division will continue, will end up with a small one speck, that is called atom. So atom is in very small in size. That size of the atom is nearly 10 power minus 10 meter. So see, atom is in very small because it is a very small speck. After further subdivision, we cannot further subdivide it. We will end up with one speck. That speck is called atom. Atom is in very small. That size of the atom nearly is in the order of 10 power minus 10 meter. So next, in this atomic physics and nuclear physics lesson, first half of this unit explained atom models, Dalton atom model, and J.J. Thomson atom model, and the Rutherford atom model, Bohr atom model, and the Sommerfeld atom model. Rest of this lesson in this unit discussed how nuclear energy is formed. Then we studied about properties of nucleus and the characteristics of nucleus, how nuclear energy is utilized in the proper way. We will discuss in this entire lesson atomic physics and nuclear physics. See, in atomic physics and nuclear physics lesson, many scientists said that atom is not a fundamental entity because it contains electrons and nucleus. Later scientists observed that nucleus is not a fundamental entity which is made up of protons and neutrons. Further scientists later proved that protons and neutrons are not a fundamental entity which is also made up of quarks. So quarks is the fundamental entity which is in protons and neutrons. Then next, in this lesson atomic physics and nuclear physics, first topic, electric discharge through gases. That is the first topic in this lesson. Already you know about the students. Air contains many gases. At the ordinary atmospheric pressure, air is a poor conductor of electricity, and air contains many gases. Many gases also poor conductor of electricity. Why? Because that gases does not contains any free charged particles like electrons. If suppose that gases contains a free charged particle electron, means it is very easy to conduct electricity through gases, but naturally at normal atmospheric pressure, at ordinary temperature, air contains many gases. It is a poor conductor of electricity. It does not contain a free charged particle to carry the electric charge from one place to another place. That's why air contains many gases is a poor conductor of electricity. Then how we make a conduction of electricity through gases? We need one special equipment, we need one special arrangement to make a gas to conduct electricity. A simple and convenient device which is used to conduct electricity through gases. It is called discharge tube. So discharge tube is a simple and convenient device which is used to make a gas to conduct electricity. It is called a discharge tube. It consists of long closed glass tube. It is a long closed glass tube. Length of this closed glass tube nearly which is equal to 50 centimeter. Diameter of this long closed glass tube, diameter which is equal to 4 centimeter. Then there is a opening, small opening in the discharge tube fitted with the high vacuum pump. With low pressure gauge. Then the discharge tube is filled with the pure form of gas usually. Then the two end of the discharge tube is fitted with the two metal electrodes. One of the metal electrode is connected to the negative end of the secondary of induction coil. Then another one metal electrode is connected to the positive end of the secondary of induction coil. So one of the metal electrode is connected to the negative end of the secondary of induction coil in this metal electrode is called Keto. Another one metal electrode is connected to the positive terminal of the secondary of induction coil. It is called anode. So secondary of induction coil which provides a 50 kilovolt potential difference. 50 kilovolt potential difference provided by the secondary of induction coil across the cathode and anode. This potential difference produces a strong electric field across the or in between the cathode and anode. Initially, pressure is reduced by using high vacuum pump nearly 110 millimeter mercury pressure. Pressure is reduced by using high vacuum pump. Pressure inside the gas in the discharge tube nearly 100 millimeter mercury pressure. We observe that there is no discharge takes place. No discharge occurs. Now, further reduce the pressure of the gas inside the discharge tube by using high vacuum pump nearly 100 millimeter mercury pressure. We observe that discharge of electricity through gases begins with the irregular streaks of light with the crackling of sound. With the crackling of sound. Next, it is a stage. At the pressure inside the discharge tube is maintained nearly 100 millimeter mercury pressure. At that moment, discharge of electricity through gases begins with the irregular streaks of light with the crackling of sound. Further reduction of pressure by using high vacuum pump, nearly the pressure inside the gas in the discharge tube is 10 millimeter mercury pressure. Irregular streaks of light disappears. There is a luminous column appears from anode almost up to cathode. That luminous column is called positive column. Pressure inside the discharge tube is reduced at that pressure 10 millimeter mercury pressure. Irregular streaks of light disappears. Then there is a luminous column appeared from anode up to almost cathode. Then the luminous column is called positive column. Why it is called positive column? That luminous appears, begins from anode and reaches at the cathode. That's why that column is called positive column. Next, we reduce the pressure inside the discharge tube by using high vacuum pump, nearly 0.01 millimeter mercury pressure. Positive column disappears. Then there is a dark space is formed in between anode and cathode. The dark space, which is often called Crookes dark space. At the time, that walls of the discharge tube appears with the green color. This is the final stage of discharge of electricity through gases. So, at that same stage, some invisible rays emanating from the cathode then travels along a straight line, reaches an anode. Then invisible rays is called cathode rays because it will starts coming from the cathode. It is called cathode rays, which is later found to be electrons, which is reaches to the anode. So this is a process of discharge of electricity through gases. So see one by one, reduce the pressure 110 millimeter mercury pressure, what happens? Reduce the further pressure 100 millimeter mercury pressure, then further reduce the 10 millimeter mercury pressure, then we further reduce the 0.01 millimeter mercury pressure. It is a final stage of discharge of electricity through gases. So at that stage, that walls of the tube fluoresces with the green color. At that moment, some invisible rays is emanating from the cathode. That rays are called cathode rays. Finally, it was found to be electrons. Dear students, now we go to see the another topic of atomic physics and nuclear physics. Properties of cathode rays. Cathode rays, it possesses a energy and momentum and travels along a straight line with that higher speed. With that speed is in the order of 10 power 7 meter per second. So it is an important one property of cathode rays. Cathode rays, it possesses a energy and momentum, travels along a straight line with the higher speed is in the order of 10 power 7 meter per second. And when cathode rays passing through the either electric field or magnetic field, it can be deflected by the electric field and the magnetic field. Direction of deflection produced by the cathode rays contains negatively charged particles like electrons. Next, when cathode rays made to fall on a certain material, it will produce heat. That is a heating property of cathode rays. When cathode rays made to fall on a minerals or some materials, it will cause a fluorescence. When cathode rays passing through the gas, ionization takes place. When a cathode rays is made to strike on a high atomic weight metal target, X-rays are produced. Yet, cathode rays travels with the speed 1 divided by 10th of speed of light. When cathode rays made to fall on a photographic plate, it affects the photographic plate. These are the important properties of cathode rays. So, see in this atomic physics, nuclear physics lesson, next topic, determination of specific charge of cathode rays, we will discuss later. Thank you, students.